Close your eyes for a moment. Think of the farthest, most distant point you can imagine, a galaxy so far away its light takes billions of years to reach us. Now go further, past the last galaxy, past the last star, past the last atom of dust floating in the void. Go to the very edge of everything, and when you get there, look over the edge. What do you see? What is on the other side of the universe? Nothing. But nothing is still a place, isn't it? It's a void, a blank canvas, an empty stage. The question isn't what you see. The question is, what happens when you try to look at a time before time existed? When you try to find a moment before the first moment? It's the most disturbing question we can ask because our minds built to navigate a world of causes and effects of before and after simply crash. We are temporal beings sailing on a river of time, and we are asking what lies upstream from the source of the river. It feels like a paradox. It feels like asking what is north of the North Pole, and for the longest time, science gave a simple, dramatic, almost biblical answer. In the beginning, there was nothing. Then, for no reason, in no time, nothing exploded and became everything. The Big Bang, a grand origin story, a beginning. But what if that story is incomplete? What if the universe never began? This is where we need a guide, not just any scientist, but someone who could look at the most complex ideas in physics and turn them over in his hands like a child examining a new toy, marveling at its simplicity. A man who distrusted authority and revered nature. A man who could explain the deepest laws of the universe with a common analogy about frozen lakes or tennis balls. I'm speaking, of course, of Richard Feynman. And if we were to sit down with him, maybe on a quiet afternoon with a blackboard and a piece of chalk and ask him this question, what if the universe has no beginning? He wouldn't start with mathematics. He'd start by asking us to question what we even mean by a beginning. He might begin by looking at you with that twinkle in his eye and say, all right, you think everything has a beginning, you were born, this planet formed, the sun ignited. That's a good guess based on your experience. But your experience is limited to a tiny corner of a vast universe. You're like an ant living on the cover of a book. The ant feels the front cover and the back cover. He might think the story begins and ends there. But if he crawled inside, he'd find the story has no real beginning or end. He can open to any page. Maybe the universe is more like that book than the cover. To understand this, we have to first dismantle our simple, intuitive picture of the Big Bang. Most people imagine it as a kind of cosmic firecracker, a tiny, dense point of stuff sitting in the middle of an empty void, which then explodes, sending matter outwards to fill the emptiness. But that's wrong, completely and utterly wrong. Feynman would stop you right there. He'd pick up 2 pencils from the table. He'd hold one up. This pencil is a galaxy. Now, if the universe started from a point and exploded, all the galaxies would be moving away from that central point, right? Like shrapnel, he'd move the pencils away from an imaginary center. But that's not what we see. We see that every galaxy is moving away from every other galaxy. It's not that they're moving into a pre-existing space. They are moving because space itself is getting bigger. Here's the crucial leap. The Big Bang wasn't an explosion in space. It was an explosion of space. Imagine a balloon. Draw dots all over its surface with a marker. Those dots are galaxies. Now inflate the balloon. As the rubber stretches, every dot sees every other dot moving away from it. No dot is the center. The surface of the balloon is all there is. For a hypothetical 2-dimensional ant living on that surface, the universe is just that curved plane. Now here's the mind bender. If you run the movie backwards, you deflate the balloon. The dots get closer and closer together. Eventually, the balloon is completely flat and tiny, but the dots are still on the surface. Run it back further, and the balloon would have to become smaller than a single atom. The entire universe, all the dots, all the space on that surface would be crushed into an infinitely small, infinitely dense point, a singularity. This is the Big Bang. The entire observable universe, all of space itself, scrunched down to a size smaller than a proton. And here's where the question of before becomes meaningless. Feynman would tap the deflated balloon with his pencil. You see, our ant wants to know what happened before the balloon was this tiny, But before is a concept that exists on the balloon surface. It's tied to the ant's experience of time within that universe. When the balloon is a single point, our entire understanding of space and time breaks. It's like asking what is south of the South Pole. The question itself doesn't make sense because the coordinate system we use to define south ends there. The singularity is the ultimate edge, the boundary of our physical laws, the curtain drops. And for decades, that was the final answer. The universe began. There was a first moment, Genesis. But hold on, that answer has always felt a little too convenient, a little too much like a creation myth dressed up in mathematics. It requires a magic point where everything pops into existence from literally nothing, not just matter and energy, but space and time themselves. That's not an explanation. It's a label we put on our ignorance. It's a wall. And the most curious minds like Feynman's, can't just stop at a wall. They have to wonder what's on the other side or if the wall is even real. So let's do what Feynman would do. Let's stop being satisfied with the simple story. Let's look at the evidence, at the clues the universe has left us, and try to build a better picture. The first clue is the smoothness of the universe. When we look at the cosmic microwave background, the afterglow of the hot Big Bang, we see that the universe is incredibly uniform. The temperature across the entire sky is almost perfectly the same, varying by less than 1 part in 100,000. This is a huge problem for the standard picture. Think about it this way. 2 patches of sky in opposite directions are so far apart that light has never had time to travel between them in the entire history of the universe. They have never been in contact, they couldn't have exchanged information or reached the same temperature. It's like finding 2 people on opposite sides of the Earth who have never met or communicated wearing the exact same outfit, down to the same socks. How is that possible? In the old picture, it isn't. It's a cosmic coincidence of staggering proportions. This mystery is what led to the theory of cosmic inflation, and this is where our story takes its first sharp turn away from a simple beginning. Inflation proposes that in the first infinite decimal fraction of a second after the universe popped into existence, it didn't just expand a little. It went completely haywire. It underwent a period of mind-bogglingly rapid exponential expansion. Imagine that tiny point of singularity. Now, in less time than it takes light to cross a proton, that point swelled to a size larger than the entire observable universe today. It expanded faster than the speed of light. And before you object, remember it was space itself expanding. It's not objects moving through space. It's the fabric of space stretching. There's no cosmic speed limit on that. So how does this solve the smoothness problem? Feynman would use another analogy. He'd take a small piece of modeling clay, no bigger than a pea. This is the primordial universe before inflation. Now he'd smash it with a book, flattening it into a wide, thin, smooth disk. Before I smashed it, he'd say, the clay was lumpy. It had imperfections. But after I stretched it, those imperfections are spread out so thin they're almost invisible. The clay becomes smooth. That's what inflation did. It took a tiny causally connected patch of the universe, a patch small enough for light to travel across and equalize its temperature, and stretched it exponentially until that one tiny smooth patch became the entirety of our observable universe. That's why everything we see looks the same. We're all living inside that one original smooth patch. The coincidence disappears. Inflation is powerful. It elegantly explains the universe we see. But here's where it gets really interesting. Remember the engine that drove inflation? It was a strange form of energy, sometimes called the inflatant field. It had a repulsive gravity, which is what caused the insane stretching. And this field didn't just switch on and then switch off everywhere at the same time. Think of it like a radioactive material. It decays randomly. In some places, it would stop inflating, dumping its energy into a hot soup of particles and radiation, a big bang. In other places, it would keep going. This leads to a truly profound and mind-bending picture. Feynman would love this. He'd take his inflated balloon, but instead of thinking of it as one universe, he'd ask you to imagine the balloon surface as an infinite inflating sea. On this sea, bubbles are constantly forming. The inside of each bubble is a region where inflation has stopped and a Big Bang has occurred. Our entire universe, everything we can see with our most powerful telescopes, all the billions of galaxies, all the light from 13.8 billion years is just the inside of one single bubble in this infinite, eternally inflating sea. And here's the kicker. The sea itself, the space outside the bubble, continues to inflate forever. It creates new bubbles all the time. Each bubble is a new universe with its own Big Bang. This is the eternal inflation or multiverse theory. In this picture, there is no single beginning. Our bubble had a beginning. Our local patch of reality 13.8 billion years ago started with its own Big Bang. But that event was just a local event, a phase transition in a much larger cosmos that has always existed and will always exist. The larger cosmos, the inflating sea, is eternal. It has no beginning and no end. It just is. Let that sink in for a moment. The Big Bang was not the beginning of everything. It was the beginning of our local region. It was the birth of our observable universe, not the birth of reality itself. The ultimate origin story is not an explosion. It's a process, an eternal quantum process. And this is the first major crack in the beginning narrative, but is it the final answer? Not quite, because we're still left with the inflating sea. Where did that come from? It's eternal, but that just pushes the question back. We can't help it. We're temporal beings. We have to ask. This brings us to the deepest, most Feynman-esque part of the inquiry. He would now put aside the analogies of balloons and clay. He'd lean forward and he'd say, all this trouble we're having, it's because we're treating time like a line with a beginning, a middle, and an end. But what if time isn't a line at all? What if it's a circle or a sphere or something even more strange? We have to let go of our intuition and let the mathematics guide us. And this is where we encounter an idea so beautiful, so elegant, and so strange that it feels like magic. It comes from a collaboration between two of the greatest minds of the 20th century, Stephen Hawking and a physicist named James Hart. They proposed what is known as the no-boundary proposal. And to explain it, Feynman would use his favorite tool, a thought experiment. Imagine you are a two-dimensional being living on the surface of the earth. Your reality is just the curved plane of the land. You can go north, south, east, or west. To you, the earth has a boundary. You could, in principle, walk all the way to the North Pole, and when you get there, you'd find the edge, the end of the world. But a three-dimensional being looking down from space knows the truth. The North Pole isn't a boundary or an edge. It's just an ordinary point on a smooth, curved surface. The edge existed only in your limited two-dimensional perspective. The Earth doesn't have a boundary. It closes smoothly in on itself. Now apply this to the universe. Hawking and Hartley asked, what if the universe, at the very beginning of its history, didn't have a singular point of creation, but was instead like the North Pole of the Earth? What if when you go back in time, you don't hit a wall, a singularity, a moment of creation? Instead, as you approach what we call the Big Bang, time itself begins to behave strangely. It doesn't just stop, it curves, it turns into something else. It turns into a dimension of space. In this picture, the very early universe wasn't a point. It was a four-dimensional sphere, a tiny hyperdense sphere. And on the surface of this sphere, the distinction between time and space becomes blurred. If you try to go back to a moment before the sphere existed, you can't, because there is no before, just like there is no point on Earth that is north of the North Pole. The North Pole is the northernmost point. In the no-boundary proposal, the Big Bang is the southernmost point of time. The universe just is. It is a closed, finite, four-dimensional shape with no boundaries, no edges, no beginning, and no end. It just is. The question of what happened before the Big Bang is as meaningless as asking what is north of the North Pole. The universe is a self-contained system. It doesn't need a creator. It doesn't need a first cause. It is the first cause. Feynman would absolutely adore this. It's the ultimate triumph of geometry over narrative. It solves the problem of the beginning by simply defining it out of existence. It says that the universe in its most fundamental description is timeless, or at least that time as we know it is an emergent property. a phenomenon that only appears in the later, larger universe, like wetness emerges from a collection of water molecules but doesn't exist for a single one. The universe didn't begin, it simply is a closed eternal shape in a higher dimensional reality. Now, this is where you might feel a kind of vertigo, a spinning in your head, because we're so used to thinking in terms of stories, beginnings, middles, ends, birth, life, death. This idea strips that away. It suggests that our most fundamental experience, the flow of time, might be a kind of illusion, or at least a simplified macroscopic view of a much stranger static reality. It suggests that the universe in its totality is like a completed jigsaw puzzle. It doesn't become, it just is. The past, present, and future all exist simultaneously in this four-dimensional shape. Our consciousness, like the two-dimensional being on the Earth's surface, is just moving along one particular path, experiencing one moment after another, unaware that the entire journey is already laid out. This is profoundly unsettling, but also deeply beautiful. It means that you reading these words right now are not just a temporary accident in a brief moment of cosmic history. You are an integral part of this eternal, self-contained, no-boundary object. The atoms in your body, forged in stars that are long dead, are just as eternal as the universe itself. The patterns they form, your thoughts, your memories, your sense of self, are temporary dances on the surface of this timeless reality. But the stuff you're made of, the space you occupy, the very laws that govern your existence, are part of an unbroken, eternal whole. But we have to be honest, we're not there yet. These are mathematical proposals, beautiful and compelling, but not proven. They are the best guesses of brilliant minds trying to peer behind the curtain, and they point us in a direction that is even stranger than we imagined. Because if the universe has no beginning, if it is eternal in some form, then it forces us to confront the possibility that everything that can happen will happen. An infinite amount of time or a timeless existence means that the configurations of matter and energy are not unique. Think about it this way. The number of ways to arrange the particles in your body is huge, but it's finite. There are only so many ways to put atoms together to make a human. If the universe is truly infinite in space or eternal in time, then the same arrangement of particles that makes up you will eventually repeat, not once, but an infinite number of times. There is another you, somewhere in the vastness of the cosmos or in the distant future or past, reading these same words, having the same thoughts, and another, and an infinite number of slightly different you who made different choices. This is the ultimate implication of a universe without a beginning. It robs us of our uniqueness. It suggests that we are not a one-time performance, but a pattern endlessly repeated on the cosmic tapestry. Does that frighten you? Does it diminish you? Or does it fill you with a sense of awe that the simple act of your consciousness, this fleeting spark of awareness in the darkness, is a pattern so profound that the universe in its infinite expanse chooses to replicate it again and again? Feynman would probably chuckle at the thought. He might say, so what? There are billions of snowflakes and each one is different. Even if there is another you out there, he's not this you. He has his own pain, his own joy. Your responsibility is still to this moment right here, right now. The universe may be infinite and eternal, but your consciousness is a singular point of view. And that is a remarkable thing. So we've journeyed from the simple intuitive picture of a beginning to an eternally inflating sea of bubble universes to a closed, timeless, four-dimensional sphere. We've seen that the question, what came before, might be as meaningless as asking what is north of the North Pole. The universe, in its deepest sense, may require no creator, no first cause. It may simply be the one eternal self-consistent thing that exists. And this brings us back to where we started, to that dark edge of everything. But maybe we've been looking in the wrong direction. Maybe the edge isn't out there in the distant cosmos. Maybe the edge is right here, right now. The boundary between what is and what is not, between the past and the future, between the known and the unknowable. That boundary is the present moment. It's the only place where the eternal, timeless equations of physics touch the reality of experience. It is the interface between the no-boundary universe and our conscious perception of it. Perhaps the greatest mystery isn't what happened before the Big Bang. Perhaps the greatest mystery is that there is a now at all. That in this universe of eternal silent geometric laws, there exists a phenomenon called awareness. That stardust can contemplate its own origins. That we can sit here on a small planet orbiting an ordinary star and ask the question, what if the universe has no beginning? The answer, whatever it is not just written in the movements of galaxies or the mathematics of quantum gravity. It is written in the very fact of your existence. You are the universe looking back at itself. You are the self-aware part of the cosmos, the part that has finally woken up and started to ask questions. The universe may have no beginning, but your awareness of it, this fleeting, precious moment of consciousness, is the only beginning that truly matters. And it began right